Hello students, in the last class we have learnt about the basic concepts of the degree of freedom, and we have derived the Kuchbek relations, Grubler relations and S.S. Rathan's empirical formulas for finding the degree of freedom. So, let us first revise what we have learnt in the previous class, and then we have go for the exceptions bounded with these formulas. In last class we have derived the relation like this for finding the degree of freedom, that was f is equal to 3n minus 1 minus 2p1 minus p2, and another formula which was given by S.S. Rathan was equal to n minus 2l plus 1, where n is equal to number of links, p1 means pairs having degree of freedom as 1 or number of lower pair. P2 means pairs having degree of freedom as 2 or number of higher pair in the mechanism. These are the some formula given by the Kuchbek, and this formula was the empirical formula given by Professor S.S. Rathan. These were both useful for finding the degree of freedom, where n, as I have told you, is the number of links in the mechanism, p1 is the pairs having degree of freedom as 1 or number of lower pairs, or p2 is the pairs having degree of freedom 2 or higher pairs. These types of formulas, these two formulas are used for finding the degree of freedom of a planar mechanism. However, for space mechanism we have to consider the 6 degree of freedom, that is why formula have a little change by considering the 6 degree of freedom. Now, we should learn about the exceptions with this formula. These formulas, these empirical formulas have some exception bounded with it. The some exceptions are, they are categorized in two categories. Generally, exceptions are due to the dimensional consideration of the links, which is not considered in this formula, and also according to the resultant degree of freedom in the mechanism if it is found in the mechanism. So, if we consider these two properties of the mechanism, then we can found some exceptions. So, we will see the examples of these exceptions in detail. First, we will discuss the first exception due to the consideration of dimensional consideration of the links. Let us consider a double parallelogram. We draw the double parallelogram, and let us see how the formula derived by Kuchbek fails here, and why it fails, as I have told you, due to the exception bounded with the formula. Let us consider this double parallelogram. To make it is a mechanism, kinematic mechanism, we have grounded the link 1, so that we can define the constrained motion. So, this has number of links as 1, 2, 3, 4 and 5. The third link, as you know, this one is the ternary link. So, let us try to find its degree of freedom by applying any one of the formula we have learnt so far. So, the formula is f is equal to n minus 2l plus 1. Here the number of links is we have 5 as it is shown here. Number of loops, as I have told you, this one is the first loop and this one is the second loop. There are 2 loops, so that is why we have L is equal to 2, and the degree of freedom now comes equal to 5 minus 2 into 2 plus 1. F is equal to 0. Its degree of freedom by the Rathan's empirical formula comes equal to 0. If the degree of freedom comes equal to 0, then such type of chain is type of mechanism is called as logged chain or structure. means it cannot move in any of the direction by applying any amount of force. So, such type of chains are called as log chain and structure. Now, we shall go for the exception. What kind of exception we may experience while handling this mechanism with the help of this formula or the Kuchbach's criterion. Now, if the links are arranged in this way, let me draw the diagram. Now, I have arranged link 5 parallel to either of the link 2 or link 4. By arranging, so we can find that the degree of freedom of such mechanism is 1, means it can move in one direction. The number of links are same 1, 2, 3, 4 and 5, 1, 2, 3 and 4 and 5. Only we have what we have changed, we have made this link 5 parallel to these links 2 and 4. By doing so, it can have the motion in any one direction and hence its degree of freedom is 1. So, these are the some exceptions by not considering the dimensional consideration. If we consider the dimensional consideration, that if we make the link 5 parallel to 2 or 4, it can move in one direction and its degree of freedom is 1. So, in this way we can see that it is always necessary while analyzing the mechanism to check the dimensional consideration. Now, let us discuss about the exceptions due to the redundant degree of freedom. Before we will go in detail, we should know what is redundant link. Now, as we have explained the first types of exception and its example, now let us try to see that what kind of different exceptions can we face. The second exception was due to redundant degree of freedom in a mechanism. Redundant degree of freedom or redundant degree is called due to any redundant link in the mechanism. A redundant link, let me define it first. A redundant link is any such type of link in a mechanism which do not introduce any constraint to the mechanism is called redundant link. It does not produce any effect to the mechanism, as I can see that in this figure or in this example of double parallelogram mechanism, if I remove link 2, 5 or 4, it will cause no any effect to the mechanism. So, let us try to define or write here that what is redundant link. If in a system there are such links which do not introduce any constant to the mechanism is called redundant link. Here in this figure, link 2, 5 or link 4 are the redundant link. And its degree of freedom is called as redundant degree of freedom. Redundant degree of freedom which is denoted by FR. Since redundant link do not introduce any constant to the motion, one of the link can be deleted to calculate the exact degree of freedom. Now, if I calculate the degree of freedom by simple formula, it is equal to F is equal to n minus 2L plus 1. Here number of links are now 4, loops is 1 plus 1. Hence, the degree of freedom comes equal to 1, effective degree of freedom is 1. However, if we take in account of redundant degree of redundant link, then the formula is changed like this. F is equal to 3 n minus 1 minus 2p1 minus p2, and since redundant link do not introduce any constant, that is why it is need to subtract it, or same it can be done to the Rathan's empirical formula, that is n minus 2L plus 1 minus FR. Now, in the next example we will see that how this formula works. For that let me draw a diagram. Let us consider this diagram. In this diagram, roller this has 4 links 1, 2, 3 and 4. This link 2 and link 4 are grounded somewhere by the link 1, and if we analyze this, we can say that link 3 do not produce any effect to the mechanism, because link 3 can rotate about its axis without producing any effect to the mechanism. That is why the link 3 is a redundant link. Now, if I apply the revised formula, I can would be able to find the exact degree of freedom. Here we have number of links is equal to, as it is shown in the diagram, 1, 2, 3 and 4. Number of links are 4, pairs having single degree of freedom or lower pair are 3, and pair having 1 degree of freedom, 2 degree of freedom is 2, and here we have redundant degree of freedom is equal to 1. A 4 link mechanism can constitute maximum 4 pairs. As we can see that this link 3 can rotate about its axis, that is why there is a possibility of 2 motions at a time, one is sliding and one is rotation. That is why this link, this pair 3, 4 is a higher pair P2. So, we have number of pairs is equal to number of lower pairs equal to 4 minus 1 higher pair, that is 3, and number of higher pair is 1 possessed by this link 3, and redundant degrees of freedom is again due to this redundant link 3. So, if I calculate now the effective degree of freedom, I can write F is equal to 3 n minus 1 minus 2 P1 minus P2 minus Fr. So, here we have F n is equal to 4 minus 1 minus 2 into 3 minus 1 minus 1. Hence, effective degree of freedom in this case is equal to F equal to 1 by considering the redundant link. Let us try to do some more example. If I give you one more example so that you can better understand the concept, let us consider this example. Again, this one is a 4 bar chain having link 1 fixed, link 2 and 3 are simple binary links, whereas link 4 can have a sliding motion inside this slide like this. It is not dependent on the other links of the mechanism, that is why the link 4 here is a redundant chain and its degree of freedom should be considered as Fr, which would be equal to 1. So, to find the exact degree of freedom of this mechanism, we need to take in the account of Fr. So, this is how the exception should be taken in account to find the exact degree of freedom. There are 2 types of exceptions, as I have told you. It is due to the dimensional consideration of the links and due to the redundant degree of freedom of the links in a mechanism. Now, we shall discuss about the log chain, which is also called as structure and superstructure. The log chain is such type of chain which do not allow the links to possess any relative motion of the mechanism. If I give the example of this 3 bar chain, 1, 2, 3. If we apply any force on any of the link, there is no any possibility of any relative movement between the links. Such types of link is known as logged chain, and if one of the link is grounded or one of the link is fixed, it is called structure. So, logged chain or structure, logged chain mechanism do not allow the links to have a relative motion between the links. Log chain mechanism do not allow the links to have relative motion between the links, as in this case. If there is no any relative motion of the links between them, then we can say that its degree of freedom is 0. Hence, This is the characteristics of a locked chain, or I can say that if I find any mechanism having degree of freedom as 0, it is called locked chain, and if I fixed any one of the link, then it is called it would be called as structure. Now, let us try to understand what is superstructure. If in any example of in any case, if I found degree of freedom comes equal to -1, then in this case it would be equal to superstructure. Superstructure. Let us also try to draw a diagram, so that I can explain that where we can find superstructure having degree of freedom is equal to -1. Let us try to draw the diagram. This is a diagram in which we will try to find the degree of freedom. In this diagram, this link has been fixed. Now, let us try to find the number of links. Number of links is founded by simply counting the links. Here we can find it by the simple counting 1, 2, 3, 4, 5, this one is 6, 7 and 8. Here the number of links are 8, some of them are binary links and some of them are ternary links. Let us also try to identify the binary links and ternary links. So, as I have told you very earlier that the binary links are such types of links from which 2 more links can be connected, or the ternary links are such types of links from which 3 more links can be connected. The binary links in this figure are link 2, 3, 7 and 1. So, we have binary links is equal to 4 and ternary links are this, this, this and this. Ternary links are also 4. They are link 1, link 8, link 6 and link 5 are the ternary links, and the binary links are link 2, link 3, link 4 and link 7. Total number of links are number of binary links plus ternary links is equal to 8, and number of loops are, as I have told you, loops are 1, 2, 3 and 4. These are the 4 number of loops. So, loops are L is equal to 4. Now, if I apply the Rathan's empirical formula, that is equal to F is equal to n minus 2L plus 1. As you can see that there is no any redundant link, that is why redundant degree of freedom is not taken care here. So, by applying the formula here we have n is equal to 8 minus 2 into 4 plus 1, that is equal to 8 minus 9, that is equal to minus 1, which is the case of superstructure. Means a superstructure is a mechanism whose degree of freedom is -1, whereas at degree of freedom 0 it is a locked chain, and if there is a degree of freedom -1 means we have provided one extra link to decrease the possibility of any relative motion if under the action of any force. That is why it is a more stronger than the structure. So, that is why it is called superstructure having degree of freedom equal to -1. In the next class we will see the working of 4-bar chain. We will try to analyze and we will try to see that how the motion of different links are relative to the other links by fixing one link.